Welcome to this 10th lecture on electrical machines 2. So, we have started by considering a single conductor motor and generator, and recall in our last class this was the situation. I mean the arrangement was this: there was a single conductor of finite length, and if it is a motor mode you must connect a supply, and if you this is your source voltage, if you close the switch it will start moving by applying left hand rule, you can find out. And from the word go, that means when initially switch was opened it was stationary. So, it will gradually pick up speed because of the electromagnetic force produced BIL, there is I, there is B, and direction is obtained by applying left hand rule, and it will start picking up speed. And if you assume that everything is frictionless here, then final speed will be attained, whose value will be such that BLV is equal to your V, and then it will settle down. Of course, when it settles down at that steady state speed, current will be 0 and everything is satisfied, no power, mechanical power output, because mechanical power output means force into velocity, no force is acting at that time, output mechanical power is 0, input power is also 0 from the supplied. Of course, your battery supplied some energy to the system, which will be ultimately stored as the kinetic energy in this conducting length. We did these things and we found out how this current and velocity varies with time and finally attains a steady state value. Of course, just for fun one is not supposed to produce a motor which will be doing no mechanical work. So, mechanical work means there will be some opposing force, and I concluded last time this is the thing you should remember, that if it is motor, if it is motor operation, then the conductor, if it moves in this direction with a velocity v, then the electromagnetic force will be also acting in this direction. And if it is having a constant velocity and if there is some opposing force present, this is opposing force, F e must be equal to F opposing for motor mode of operation. So, electromagnetic force and opposing force, they will be acting in opposite direction. Direction of motion is decided by F e, F e decides what is V. For generator mode, it will be like this, the direction in which it will move is decided by the external force I have applied, and electromagnetic force will be in the opposite direction. And when these two are equal, it will run at a constant velocity v. Just one point I would like to tell, because the next course of action in understanding rotating machine will be to go from linear to rotational thing. Before that, I would also like to think in this way. For example, you have a field pattern, field north here, say north here, and then there is south there. These things we were discussing. So, this is south and a conductor is moving in this direction. Suppose and suppose let me call it south to be consistent with our earlier diagrams. So, lines of forces will be like this here, is not south of poles. And suppose let us consider motor mode. If it is motor mode, that means I am injecting some current into the conductor and let the direction of the current be dot. If it is dot and if it is south, so conductor will start moving. This is B, this is I. Left hand rule you have to assume, and conductor will start moving in this direction if it is motor mode. Therefore, now I would this direction is achieved by applying left hand rule, no doubt, but you can do another thing, that is when this conductor moves and this conductor carries current, it will produce lines of forces which will be like this here, is not several lines of forces. This the field around the conductor will be like this. Now, I also told you that if I draw a single line instead of drawing so many flux lines, representative way of showing the field lines is in this way. Where the arrow is, you will expect this side is south and other side is must be some north, from which you can always imagine like that. Now, so this is the thing. Now, if you look at this arrow here, this flux lines, you notice that this I will think that here is a small s and here is a small n. This lines of force is there, okay, it is heading towards south like this, and this is north. Similarly, if you look at the lines of force of these stationary magnets, it is like this. So, I will always think that okay, there is a north pole here and south pole is here, fine. Therefore, this south and north will be attracted. Similarly, on this side, this is the south pole. So, this is north here, and this any of the lines of force you take there, this is heading for a south and this is small s and this is small n. Therefore, what we notice is that this current and magnetic field, they interact and give you torque or force, that is fine. But another way of looking at the thing is, the argument is like this, okay, on the stationary structure you have got some south north poles and the conductors which will be moving eventually, and if it is carrying some current, it also produces some north south pattern, and it is the interaction of these pole patterns that will give you motion. For example, I will say this south and here is a north of the capital N is by this ones, this will have an attractive force here. Similarly, if you consider this side of this one, this is north and this is also north, small n, and this lines of force north, okay, they will repel. So, you will get a force like this, and eventually it will move in this direction, vertical components cancel this that way also you can think. In other words, what I am trying to tell, to know the direction in which the conductors will move, one can imagine ultimately it can be traced down to this particular fact that two sets of magnets are interacting with each other. One set is produced by this structure which is not moving south, north, whatever it is, and the other fellow is the conductor which is supposed to move be it motor or generator, but it will carry some current at a given instant of time, and depending upon the direction of the current, I can draw the flux lines it creates, and recalling this fact, any flux lines you draw like this means this tip is heading towards the south pole and this side is a north pole. With this simple argument, you can easily see indeed the conductor will try to move from right to left in this particular case. Okay. In my last class, I also told you that this type of single conductor generator is not very practical. You get very little voltage, perhaps you can connect another coil, connect them appropriately in series, get twice the voltage, all these things I have done, but constructionally it is not a good practice to have mechanical power from electricity for motor operation. So, the nearest thing that I can have is I will first draw, then I will show nice diagram. That is, I will make an arrangement in this fashion. Suppose here is a north pole and here is a south pole, and I will make it circular like this. These are iron, soft iron. I can do like this, and by passing some current here, and suppose around this projected pole. So, this is circular, this is iron. If you pass some current here, you can make it like this. Suppose the current direction, this is a coil wrapped around this projected pole. Suppose this is cross dot. So, lines of forces will be like this. Therefore, this will behave like a south pole because flux lines are entering. Similarly, here on the opposite side, you in this projected pole, you make a coil, wrap a coil around this projected pole, and you pass a current like this, cross dot. Then the lines of force which will emanate from this will be like this. So, this will behave like a north pole. So, in essence what I am trying to tell, these magnets could be permanent, but as well as it could be electromagnets by having coils wrapped around the projected poles and you pass some DC current. Here the advantage is you can change the strength of this field by varying this magnitude of the current wrapped around it. So, this is the scenario I make. Then what I do is this, I take another iron piece which is circular in nature, and there, and these are all cylindrical, perpendicular to the plane of the paper, the same, it is the sectional view of a three-dimensional thing which is perpendicular to this, that is, this one is length. In essence, if I very badly I mean draw, but quickly, it is like this here, circular. Are you getting? I mean three dimensional. So, length is perpendicular to the paper. Now, what I will be doing is, I will this is a solid, suppose iron cylinder, where I will cut what is called a slot like this, a groove, like your gear thing, that is this way I will cut. So, these are all iron, but here it is air, you have cut it. Now, here you can place a conductor, forget about this slot, single conductor. I can place a conductor like this. Okay. And this will resemble our single conductor generator here. In which way? In a very limited space, everything is squeezed now. Suppose this is moving in this direction. You are turning this, this is supposed to move and it is called rotor, it has got a shaft. Suppose by hand I am moving it. Then is not it same as suppose you imagine that. So, what will happen? This conductor will move, it will come under south pole, remain there for certain time, then it will further move, then it will enter under north pole, and once again it will come to south pole. Is it not same as a equivalent machine like this? South, north, and here is also iron, and here is a slot, single slot, it is also iron. So, what I am essentially doing is I am cutting this. You imagine you have cut this with a something, you have cut it and wrapped it out like this, and you will get this, that is you cut it and unfold it. So, this rotational circular things will now appear to be linear, and this will be your, this iron is this iron, and this iron is your stationary part iron which is not moving, and this conductor is here. So, it is moving, but here it will be moving like this, and after it crosses south pole, then north pole, then once again in this one circular diagram it will face south pole once again, and once again it will face north pole. So, this arrangement is equivalent to an infinite south north poles present, and this fellow is moving. Is not this just similar to this one? Anyway, so this is how I can make a single conductor generator, and if you turn it on, it will always induce voltage here across it, across the conductors. And if it is be it generator or motor mode, this fellow will also carry current, this conductor, and this conductor will also produce a magnetic field, and this magnetic field was produced by what is called the stator coils carrying current. Stator coils, they will carry current, and these two fields will be produced. Let us call it SS and NS. This S stands for stator, the part. Therefore, every rotating machine will have two parts. One is a part which will never move, fixed, and another cylindrical part where there will be slots, where there will be conductors, and this is free to rotate in any direction, this way, that way. Therefore, I would expect, for example, if I pass some current in this direction, say cross current, I am passing through this, I am so bad. So, this is cross current, suppose this conductor, then this is the current, and the field, this is still south pole here, lines of force will go. So, it will try to move like this. So, you will get motoring action, and for this you do not require infinite space and things like that, everything is circular and the conductor will go on seeing various poles. To make this matter, I mean what I want to say is, before coming to that, let us see this one. So, now I will use two conductors in this structure. So, suppose I will, and we will come to this over and over again, do not worry about. So, suppose this is north pole and this is south pole, let me draw quickly, and this is the iron, these are all iron, and it might have some coils to create your north and south pole. This becomes south pole, this becomes north pole, we have seen. Now, what I can do is this, I will, and this is the rotor, and here instead of a single slot, I will connect two slots in diametric opposite positions, and here I will connect one conductor here and another conductor there. This conductor at the back end I will join them, that is, this conductor runs like this conductor runs like this, and I will join them in the backward direction. It was like I was telling that this is say x 1 y 1 and this is x 2 y 2. And then these two conductors, if you join at the back in this fashion, then I can call this to be a coil. And by placing these two conductors in these positions, I have ensured one thing. What I have ensured is that when x 1 y 1 will be under the center of the south pole, I am sure x 2 y 2 will be under the center of the north pole. And these two EMFs, if it is plus minus here, this will be minus plus there, and then the voltage across x 1 x 2 will be twice of these two voltage. This is VLV, this is VLV, but the polarities are such that these two EMFs get added up and you get sum of these two voltages appearing across x 1 x 2 if it is operating in generating mode. Suppose in generating mode, what are the things we have to give? Create the field BLV, B I have created, L length of the conductors that is there, and this velocity I must provide by some external agency, say turbine or by some diesel engine, whatever it is. This will be provided by tangential velocity is V. You give rotation. So, you will replicate this situation here, okay. And these two are connected in series by a flexible wire at the back end of this one, and so you will get twice the voltage. If somebody says, suppose I mean you can always think various ways. Suppose you put a slot here and you put another slot there, and these two you add in series. Okay, this will also work, it will also give you voltage between x 1 and x 2, but not the maximum voltage, because of the fact if this is say south pole and this is north pole, then the voltage pattern of this coil will be the B pattern existing here that we have explained last time, and identical voltage will be created in the second conductor if the direction of rotation is like this, but only after this much angle, and the difference of these two waveforms will give you the resultant voltage. And if you arbitrarily place the second conductor, it will never ensure maximum voltage you will be getting across the combination of these two conductors. Therefore, it is always when you new term used is a coil. A coil will have two conductors, or more correctly told, two coil sides. These are called coil sides. Coil side. This is also called coil side. So, two coil sides connected in series is called a coil with two free terminals x1, x2 available to us for passing current or collecting voltage from those two terminals, depending upon whether it is operating as a motor or as a generator. More to this will come. Before that, therefore, at this stage I will not do any mathematics, but what I will try to tell you, try to imagine in this way that every rotating machine has got two parts. One part which is made of iron, soft iron pieces, which will never move, fixed, grouted to the ground with nut bolts, so it is not allowed to move. Another cylindrical thing which will have a shaft, it is free to rotate. Okay. Then I say that this stator body, this is the stator and this is the rotor which is free to rotate. The stator body will have some windings, for example, these coils carrying current. So, stator one part and it has coils to produce field, to produce NS and SS. What is this S? North pole and south pole produced by stator. Rotor 2 similarly has coil, stator has coils, has coils. Similarly, rotor has conductors or coils to produce its own A, NR and SR. And it is these two sets of magnets which will interact to produce electromagnetic torque. Anyway, I stop here, then in the next class I will continue with this. Thank you.